Let's consider the two key categories of error, which are considered to be random and systematic. Now, also I want to bring up a term that you're going to see in your workshop, and it's one that I definitely like. It's called a blunder, because what this does is it helps separate out the really obvious stupid stuff that happens as an accident. It helps us understand when we're just not being controlled enough in our work, and it's resulting in some sort of an error. And it also gives us a term for when things are just acting the way that nature acts. And that's going to be something that we can never totally remove, but that we can do our best to minimize anything else contributing to. And we handle them differently mathematically, and we handle them different conceptually as well. So let's go into these three categories and see which ones are which. Now I'll call random error, just as a very crude shorthand. This is going to be the error of nature. We can never totally remove this. This is going to be from all the random effects that are always present in the world. But notice the key word I just pulled out and also the name of that section, random. It must be a random behavior. If there's any pattern to it, if there's a bias to it, then it's probably not purely a random error. There's probably something else hiding inside of it. Now, a systematic error is when there's actually some sort of a system. There's a method to the madness. And that's usually because you're not handling your glassware properly. Now, one example of that would be that if you're always looking from a little bit above the meniscus, you're always going to be misreading exactly where the value is, because your line is going to ghost a little bit higher. Just think through how a needle would look with something hiding behind it. If you're a little bit higher, the water level is going to appear to be higher with those lines, so you're going to be misreading all your values to be high. That'd be an example of a systematic error. Now, that said, you can also have systematic errors that give a random distribution of error. If you're systematically being bad with your glassware and you're not being controlled in your movements, that's really going to be a problem for us. Now, that said, those cases start to get right to the dividing line of systematic error and blunders. Because if you're making mistakes that end up creating their own random error that shouldn't be present in the situation, what you're basically doing is you're creating some sort of an extra phenomenon that isn't being well controlled. The lack of control of the properties of your system makes it into, in part, a random error. And the fact that that phenomenon shouldn't be present at all is because you have a systematic error that you've instituted as well. Now, one example of that might be, I don't know, if you have something that's creating that's light being absorbed by a system, and the pulses of light are happening at random, the temperature cooling effect is going to be very much a constant. You could end up having a case where the random error of thermal noise in your experiment is still present, and it will always be. But you're also going to have some sort of a systematic error if, in the process of setting up your equipment, you manage to put something in the breeze path that was helping with convective cooling to keep that temperature fairly constant. That would be an example of a systematic error. Now, if that object tends to be moving in a somewhat random pattern, like your hand or your body or your head, it will be a systematic error that has a random change in the cooling properties of your system. So it's random in its behavior. It's systematic in the fact that it's something that is because you didn't handle things as well as could have been done. So that's definitely a complicated example where you can say that something has a bit of both. Most of the time we can really kind of distill it down, though, to come up with a single final answer. Like I said in my example, if my body is blocking the convective cooling of my object, then that's a systematic error because I'm getting in the way. My behavior and my movements may be random enough that it propagates in to create random noise, but the core root of it is systematic. Now, even then, that tends to be something that happens uniformly across the board when you're doing some work. But Then there's also going to be the cases where something unique happens. That's going to be considered a blunder. Now, most books are going to flat out tell you, well, these aren't forms of error. These are just not supposed to happen at all. If this happens, it's your fault for not restarting the experiment and accounting for it. And that is true. Now, that said, blunders can sometimes appear too late for you to catch in time. Maybe you're sitting there frantically writing down data in a very fast-paced experiment, and you find out you've transposed two of the numbers. The good news is some blunders can be fixed after the fact. You look at it and you say, oh, that's obviously not right. I obviously wrote that number backward. I just need to flip these two digits, and things are fine. And as long as you can support that from evidence, then that's okay. That's not doctoring your data. If you catch yourself trying to doctor your data, slap yourself on the hand, call yourself a naughty, naughty person, and don't do that. We want to treat data almost religiously. You don't do anything to data that's not proper. And you certainly don't create your own bias to it. The values should end up being what the values will be. Nature is what we're trying to understand, and so you let nature run its course. If you have some other agenda, please find a field where having an agenda is a good and powerful thing. Use your science background and join a NGO or a governmental group or an advocacy group. But don't stay in the sciences if you're going to allow those biases into your data. Okay, that was definitely a very prickly, high-handed sounding one, and I know it, but it is one of those things where we have to be very, very cautious because you hear scandals entirely too frequently in the news. And it impacts everyone in every scientific endeavor, not just field, but every scientific endeavor, and it really taints the public perception of science. So, coming back from my tangent, we want to make sure that we didn't sneeze into our sample. That would be a blunder. We don't want to drop our sample. That would be a blunder. We don't want to make typos. Those would be blunders. Some of these things can be fixed. We can throw out that sample. If we were being silly and weighing a sample and using our scapula to keep on sprinkling sample, and some of it ended up on our pan, that was a blunder. Good technique should have prevented that in the first place. You should take the whole thing out. You should brush all of this crud off of the balance. You should re-tear it. While you're there, make sure the balance is well balanced. You know, the little bubble level shows that the bubble is sitting right in the middle. Little floating thing of mercury or a metal dot, and it should be centered up in this bullseye. There's usually a little ring here for you to kind of guide your eye with, just to make sure that it's there. I know that looks a bit like a bloodshot eye, but we'll just pretend that that's part of our analytical balance. Okay, so we're sprinkling that in. We didn't get any onto our pan because we were doing it properly and doing all of this outside of the balance and then setting it back into the balance for measurement. I know that you would never do something so silly as weighing things out and sprinkle it into your weighing vessel right there on your balance. But if you were that silly, you're probably going to be generating a blunder. Systematic errors would be if there was that crud on the balance the entire time and we didn't know it, and it was after we had already teared our glassware and we only teared it once. Then it would be a systematic error that came from a blunder. So always take a look at what is the final effect of whatever error we're talking about. What's its root cause? And then you can also talk about other things that would be impacting it in the moment. But those are going to be our two primary categories of error, and our third naughty kind of error, blunders. Blunders shouldn't happen.